Move to the next presentation by Timm Wunderlich from the TU Bergakademie Freiberg, who will share with us his thoughts on brines and mine water geothermal energy, a green energy source for different heat sinks.
Yes, thanks.
So let's go further. You're welcome. The topic is already mentioned, so I will go further with the brines and mine water geothermal energy for different heat sources and heat sinks. So now it works. So a little picture for mine water and maybe brines. We are going here for surface mining, with brown coal mining for instance, and how we can go further by the mines and for heating, so energy. So we can use mine water, you can see it here, and the low shallow water here. So with different types, we got here an open system, which is mostly common in the energy sector. So, but first, mine water, I think you are always familiar with it. It's water that's contaminated by rocks that is mined by humans, by drilling into mines, by mining in open pit or underground mines. We have got here a picture from Freiberg. It's the Rotschenberger Stollen, who has got the whole water of the Freiberg region, mining region, go through this underground river and make the whole system a little bit drier, and goes with the water to another river 50 kilometers far away. Other pictures are, we have got here some mine water lakes in the Czech Republic, Most, for instance. So all the water is contaminated and always get in contact with mine and mining operation. So this water has a huge potential as made brines as well. We always go by around about 10 to 30 degrees Celsius, and the water body as well, brines, is huge because in mines, for instance, the whole underground body where the brown coal, tin or copper was stored before from the earth is going out and produced for smartphones or cars, and so there's a huge volume there, and it's filled with water and by the geothermal gradient, so it gets warmer, and we have got 10 to 30 degrees Celsius, maybe more. And there is a huge potential made in the Ruhr area. In Germany, we've got 100 millions of cubic meters of water is pumped out of the area for getting it dry, because the whole Ruhr area is going down for 10 meters, and if the water rise up, so these were a big lake into the western of Germany. And we've got here like the same problem of brines, or not a problem, a source for potential heat. A heat for the brines in the process for creating lithium and other big raw materials. And as well, we have got the brine. It's going from down on the earth, and it's warm, and we could use it physical by heat. so we can support process heat in the industrial site. And if there are overheat by different factors, so we've got much more heat there, we can go by district heating and cooling supply for buildings into the industry area or for the worker homes. So how could we imagine this? We've got here, for instance, this is like a brine, a borehole, or here in this picture, it's like a mine, a borehole from a mine. And there we have got like a grid here for a quarter, where are different households there, and there the temperature by 10 to 20, 30 degrees Celsius goes there and could heat by heat pumps, houses, and processes. And this is in the whole European Union, or in the whole Europe. We have got different types by geothermal systems, borehole systems, mine water systems, groundwater systems, lake systems, and this is all still running. And all the year, 3 or 4 systems are going into process and getting more and bigger and bigger. For instance, here we have got the Herland project in the Netherlands. It's like the north of Aachen, here in the Netherlands. With a deep coal mine, was operating since 2008, and with different boreholes, they operate a huge system in the city, where around 800,000 square meters were produced or were supplied heating and cooling. And it runs by heat from around 35 degrees Celsius and a cooling net by around 70 degrees Celsius. So by low temperatures you can run a whole system and cool and heat the whole area. And in Saxony we've got the same as well. So how we as institute go on this question. We've got a map, for instance, with different boreholes or mines. So all the volume under our feet that's like could fill with water and capture water. So go further with a model, a 3D model from the whole city center and buildings. There we can sum different heat potentials and cooling potentials, and so we go further to calculate in a way how we can combine the potential of the heat under our feet with the demand above. And so here I've got a little map. There's Freiberg, so in the east of Germany. And there's this Rotschenberger Stollen, who is transported a huge volume of water all the time, always the next hundreds of years, thousands of years, if it's maintained. And so the degrees Celsius is not that high, it's 40 degrees Celsius, so hopefully in the Brine we have got more. And we have got as well upcoming deep water, and we use this one with a geothermal mine power plant. We have got here this Rotschenberger Stollen by 40 degrees Celsius and the upcoming deep water by 90 degrees Celsius. And with a heat exchanger and some heat pumps, we can heat and cool university buildings. And here the same as well with the different potentials. So the whole system, there are server rooms, there are buildings, there are offices. So not only like homes for different people, so it's for the university. And here we have got a little analyze from us. It's like a whole day in the winter week and the summer week, only for heating. And we've got the coefficient of performance. It's like the efficiency of the whole system. And the Rotschenberger Stollen runs by 40 degrees Celsius. In the winter week, we've got around about 4 to 4.5, about 4. And this is quite good because you use one potentially 1 kilowatt hour of electricity and make 4 kilowatt hours of heat. And in the summer, we've got the same, but it rises up to 10 because we could use the cold of this Wunderlich and use the cold for server rooms and cool them. So the whole system runs with a COP up to 10, in an average by around 7. So, and if we combine this to brines, we can use the brine heat for the different production processes in different steps. So maybe we can cool the brine at first and use this for, I don't know, I'm not a chemist, so for different products. And then we can also heat the brine as well for getting lithium, and then we have got some heat here, some rest heat, and we can use this for different buildings in the area, so we can make the whole system more economic, flexible. So the heat for the process and the heat made for some heating and cooling supply in the later, in the later one. And here a little side note, a little problem for the heat recovery. Some heat exchangers. We need at first temperature levels and the volume flow, and then we've got here the heat exchanger where we can calculate the potential of the heat and cooling demand, what we can use from the brine. And the heating, the volume and the temperature is really important for us because without them we cannot make like a guess how much we can supply to the other colleagues. And so far there's as well the problem of fouling and scaling. I think we can talk to this in the lunchroom or by a coffee. So thanks a lot. And I hope you've got some questions.
Any questions to Timm? Everybody very shy. Maybe I'll ask a dumb question. I'm an ignorant, pardon my ignorance in this field. How significant is this use of the heat from geothermal sources in Freiberg?
In Freiberg?
What you showed, how important is it? Because we know, for example, I imagine you can't use it to grow bananas like in Iceland they do, but is it just, something, is it meaningful?
Not now, we are under, we look on it in Freiberg. There's a potential, a bigger potential than nowadays. And with the whole situation now, it gets more and more important. But in my opinion, we have a big mine under our feet in Freiberg, and the huge customers there with industry and so on. And the industry has got as well like waste heat, so we can combine these two. There is a potential, and there will be in the future a higher potential that we think there will be. Yeah.
Okay, thank you, Timm.